Hey y'all, I'm back. So, took about a year off. Been a crazy one, as most of you know. Got a lot to talk about in my philosophy videos. And so, but yeah, man, gonna revitalize the channel, get back to it. Miss doing it. Looking forward to being able to, do what I want to with it. Wanted to do with it to begin with now. So yeah, and I figure, coming back, we can introduce a new segment, right? And so in this segment, we're going to be going through Hackerrank. This is still used to vet a lot of candidates and things like that. I'm not really sure. Got opinions about that, but it's still being used. It's still relevant. So I figure what we can do is we can go through it. I know I did Hackerrank a long time ago. I don't even remember the email address I used. Can't get back in that account. But so I started a new one and I went through a few of the algorithms, data structures, database, and SQL stuff yesterday. I figured that's what we'll focus on. Now these are not going to be super deep dives, right? Because there's just no time. So really, this is going to be about how I approach solving these kinds of problems. I'll be explaining the questions to you a little bit. And I'll explain some things as I go through the implementation. But this is really to show how to think through these problems and answer them. The little intricacies, little Rust things that I introduce, I'm not going to go super deep into those because this would just take forever to do. All right, so I figure, we'll do 10 or 15 minutes, see what we can get through, and if for some reason we burn through them all, we'll just do a new one together. But yeah, we'll go through them and see how far we can get. Okay. All right. So let's start with algorithms. Yeah, let's do an algorithm problem. Okay. Oh, new. That's pretty cool. That makes sense. They add new ones every once in a while, I guess. Not even going to bother doing that. We'll start here. Okay, you see Hackerrank remembers your solutions. I'm going to delete the solutions and delete my notes and try not to look at it before we do the implementation. That way I can kind of walk through it fresh with you. And my short-term memory is terrible, so it'll be like doing it new every time. Okay, so yeah, as you can see here, this is just summing an array, right? That's all this is doing. So in Rust, it's obviously quite easy. Basically take the array, produce an iterator of references, turn them into values, and then sum them up. Pretty easy. All right. There we go. Success. All right. Let's do the next one. Oh yeah, this threw me off because I was like, there's no way it's the same thing. It looks like they're asking about the same thing. So yeah, you can just do this the same way. That. All right. And we are successful. Cool. All right. Exciting stuff. Let's go on to the next one. Diagonal difference. Yeah, so this is the one where they want you to calculate the diagonals of a matrix and return the absolute value of a subtraction. Okay? So really the only trick to this one is knowing how to capture those diagonals, right? Which is easy. It's the same way, and no matter what programming language you're using. Okay, so first we have to capture the length to be able to calculate the diagonals, right? So get the array length. Okay, and then we'll do primary for our left to right diagonal. I'm gonna bump this up one. Okay. And then we'll do secondary for our right to left diagonal. And then we need, they want absolute value, right? Yes, they want absolute value, which is easy to do in Rust. Right. Absolute value is just the positive number, right? Based on a number line. The value, pretty much. Okay. Now, get the length. And we'll use map here. Pretty straightforward stuff. And then the formula for capturing the left to right array is this, right? Because you're capturing 0, 0, 1, 1, 2, 2, 3, 3, etc. Right? Pretty easy. Now, for the secondary, a little bit different. Shortcut keys all over the place. Okay. And then we'll do map. Same thing. And then the formula for capturing this diagonal is length minus 1 minus I, right? And that's how you get that diagonal. And then for the absolute value, sum. And then for the absolute value, we can just do primary minus secondary and return the absolute value. That should work. Nope, got an error. It cannot infer type. So, right, you'll see the error. They actually, you know, at least it gives you error messages because it doesn't give you much for auto completion. Right, so if we scroll down, we'll see, right, cannot infer type. So we just go in there and tell it the type. And that should be it. Good deal. All right. Let's do another one. Plus minus. They name these things. You have no idea what they are by the way that they name, what the problem is by the way that they name them. Okay, I'm going to delete these. Oh, okay. So this is the one, they basically, they just want you to, calculate. So right, they're going to have, so the first entry is 6. That's the number of elements in the vector. And then you're going to have your 6, right? And then -4, -9, 0, 4, 1, and 3. And they want you to calculate the averages of those, right? So the averages of your positives, your negatives, and your zeros. That's what they're looking for here. Okay, so for this, well, we need to calculate averages. Oh, and they want these to be to 6 points of precision too. So we calculate the averages. We need to define, or we need to get the length to calculate averages. Then we need to define variables. We need to define mutable variables to hold our numbers, to hold our values, I guess. Then we can use. Then we'll iterate over the array. Conditional branching to add to our variables. And then we will print out the solutions with 6 digits of precision. All right. So we'll just use n. Let mutes. So we need positive equals, oh, and these are counts, so we can set them to unsigned. They should never be negative. Right, perfect. Now, we can use, so we can use the referenced element pattern here. The referenced element pattern is just this. It gives us automatic dereferencing, right? So if x is less than 0, x is greater than 0, else 0. Right. Now we can just print. Man, no auto completion, guys. None. Like, come on now. Positive. We got to cast it to a floating point to get the precision that we need. And so this is how you get. This is how you define precision, right? In Rust. Right here. Oh, don't forget to do this, or you'll get an error. You gotta do that too. Okay. Now. That should be it. Cool. That is it. Looks good. All right, we are at 11 minutes already. Wow, that went fast. Let's do a data structure. Let's do one data structure. Let's see. Oh, this is just so this is just reversing an array, guys. Pretty straightforward. Yeah, you're just reversing an array. Very easy to do in Rust. You can just do a dot iter. Basically the same thing that we did in that the summation of the array. Copy dot reverse and then add it to a collection. Right. That'll be it. Boom. There you go. Let's do one more. That was a little lame. Let's do one more. Not so anticlimactic, hopefully. I don't really remember what these are. Oh, yeah. So this one, I was kind of like, for real? With this one? Like, I would say that this is a medium difficulty question. They have it listed as easy. And primarily, it's just, I think it's understanding the question, really. Like, there's a lot here. And, yeah, I just don't agree with this being easy. I think it should be medium, but whatever. So, really what this question's about. So, like I said, I can't go deep into this stuff, right? There's not enough time. But, so basically what this is so here, right here it's just size of array, size of queries, whatever. Okay, but really the thing here is, so this is your mode, this is your modulus, and then this is your value. Okay, and so when you have 1 in this position, that means write to the queries. Okay, I mean this means write the value to your sequences, right? Your container. Okay, and 2 means read from that, right? And there's some modular arithmetic that goes on here to be able to grab and to write these values consistently. Now, really what this is about introducing state to your code. The whole problem here is, instead of just, a lame read-write situation, this causes they're having you persist some state. Because what you're doing is you're returning the last answer, okay? And so you're maintaining that last answer. So yeah, it's really about layering it, being able to layer state into your code, right? like adaptive routing and just state stuff, right? Being able to implement state into your code. Okay, like I said, there's a good bit to this. So we'll walk through it. So one, so n needs to be captured as usize. You'll see why. We need variables for last answer. We need an output vector and sequence and some kind of sequence to hold our queries. Okay. Now there's a couple of formulas here. I think they actually tell you the formulas. Yeah. So here, right, your Zoring last answer, and here your well, they're only showing you the last, and they're not really showing you the full formula. So yeah, there's a couple here you need to know, which I'll show you. So yeah, so after this we need to iterate over the queries. Okay. We need to capture the mode, modulus, and value. We will then use well, we need to define, so you have to get the bucket, the index of the bucket, and the index within the bucket, the position. Read about that. Analyze. If you don't understand this problem, you'll actually learn a good bit just by analyzing this problem. Okay, especially about bitwise operations and modular arithmetic. Yeah, you have to calculate the bucket index, right? And so that is done. Well, I'll show you in the code. Okay, and then we need to. Then we'll use a match statement, right? We'll match on the mode. Okay, so if we get 1 back, well, that's, like I said, that's right. If we get 2 back, that's read. There's going to be some stuff that we're going to have to define and read, this is where we will do the position formula. Okay, and then 9 will be our catch-all, or this will be our catch-all. And then we'll just return our output vector. Okay? Okay, so let's do this. So let n equal n has usize, which you'll see here shortly. Let mute last answer equal 0. Let out, this is just be a new vector. And then just call it, I think I called it seeks. This is going to be a vector of vectors containing I32s, and then we'll just use the macro here to create, yeah, like that. Okay, right, like that. All right, now we need to iterate over the queries. Okay, and then we're going to capture our things, right? So that's our mode. That's our modulus. And that's our value. Now, what we are capturing is these, right? Look at the input, right? This is what we're capturing here. Q0, Q1, Q2, okay? Right there. So that's what we're capturing here. And we're basing the match off of that. We're going to base the match off of that, okay? Now this is the index. This is for the bucket index, right? So we'll just call it IDX. Now we take the modulus, we XOR it with our last answer. I need to change that shortcut key, y'all. Has usize and then modulo in. Okay? Now, we're going to match on T, our mode. So 1 is right. So we're just going to right, that's what we're using. Is it? This is that index is basically allowing us to write where we need to. Okay, and then we're going to push our value onto there. Okay, now 2, and then our catch-all. Now, oh yeah, so this was wonky. There's because the position formula can be, it can look a little ugly. It has to be, so it's better to compose it. So you want, so you, it's the length of this, really. That's what you're looking for. It's the length of the, it's the position, right? So right, it's the length of that. Okay, and so then you can do all right, you got to take the Y and then modulo that length. All right, so like that. All right, now we can do last answer. It can just be those, okay, and then out dot push last answer, and then we can come down here and do out, and that should be it. Let's see. Nope. Oh, that's just a typo. Yeah, there it went. Cool, guys. So this one's a little hairy, right? So I suggest going through and studying this. And like I said, if you don't understand what it's doing, you can actually learn a good bit from this question about, yeah, bitwise operations and modular arithmetic. So, yeah, guys. So we're way over time, as usual. So yeah, I hope you dug it. I hope you learned a little bit. We'll keep on pushing through these. There will be a new algorithm and data structure video this week. I am not sure if I am going to do ring buffer, which was the last video that I did earlier this year, so I need to do implementation of that. Or we may do breadth first search. We did depth first search, so we may do breadth first search next. I don't know. And then there's a bunch of other stuff I want to do too. So, but yeah, guys, appreciate you. Hit me up if you have any questions about this stuff. Help each other out in the comments. Ask respectable questions to get respectable answers. And I'll definitely see you in the next one.